Hi everyone! This video is the final installment of our blockchain series for beginners. In the last video, we learned about how blockchain is created. Now, let's take it a step further and explore different types of blockchains, consensus algorithms, and blockchain generations. By the end of this series, you'll have a comprehensive understanding of blockchain, and you'll see that it's actually a technology you can master. Lisa heard that thousands of blockchains already exist, and that new blockchains will continue to emerge as blockchain technology advances. Wow! This opens up a world of possibilities, and at the same time, it is overwhelming. Understanding the different types and characteristics of these blockchains is crucial, as it can help us make informed choices and select the right services that align perfectly with our needs and goals. To get started, blockchains can be broadly categorized based on two main criteria. First, mining conditions, and second, participation conditions. To make this easier to grasp, I've prepared a helpful diagram for you. Public blockchain. Public blockchains are open to everyone. Anyone can join and participate. Bitcoin and Ethereum are great examples. Private blockchain. Private blockchains are limited to a specific organization or group. Hyperledger Fabric and R3 Corda are examples of private blockchains. Permission blockchain. Only users with special permissions can validate transactions. Ripple and Quorum are examples. Permissionless blockchain. Anyone can join and validate transactions without any restrictions. Bitcoin and Ethereum fall into this category as well. As we discussed earlier, the four main types of blockchains can be combined. For instance, commonly known as a public blockchain is a public permissionless blockchain, while a private blockchain is a private permission blockchain. Beyond these, there are also hybrid blockchains that combine the advantages of both public and private blockchains, as well as specialized types like consortium blockchains, sidechains, and interchains. Do we need both public and private blockchains? Absolutely, we need both public and private networks because they serve different, crucial purposes. Public blockchains, like Bitcoin and Ethereum, offer unparalleled transparency and decentralization, making them perfect for cryptocurrencies and applications requiring trust without intermediaries. They're open to everyone, fostering innovation and resistance to censorship. On the flip side, private blockchains, such as Hyperledger Fabric or R3 Corda, provide the control and privacy that businesses and regulated industries demand. They offer faster transactions, customizability, and the ability to comply with complex regulations. While public blockchains democratize access to financial services and promote open innovation, private blockchains enable enterprises to harness blockchain's power for sensitive operations and data management. Together, they form a comprehensive ecosystem that caters to a wide range of needs, from individual financial freedom to enterprise-grade solutions, ensuring that blockchain technology can be adapted to virtually any use case in our increasingly digital world. Therefore, choosing the right blockchain depends on our specific needs and purposes. Lisa feels more confident about blockchain now. Nice! I hope you do too. As we now all know, the philosophy and purpose of blockchain is decentralization. The core of blockchain technology is how participants in the blockchain reach consensus on trust without relying on a central authority, using a peer-to-peer P2P network. This process is known as consensus algorithms. Just before we start with consensus algorithms, if you want to know about why we need to go for decentralization, this video will help you. Generally, public blockchains use three main consensus algorithms. You may have heard of them. First, proof of work, POW. POW is one of the earliest and most well-known consensus algorithms. In this system, miners compete to solve complex mathematical puzzles to validate transactions and create new blocks. The first miner to solve the puzzle gets to add the block to the blockchain and receives a reward. Bitcoin, the first and most famous cryptocurrency, uses POW. While it is secure, it requires significant computational power and energy consumption. Therefore, current blockchains tend to use proof of stake, POS, instead of POW. Second, proof of stake, POS. As we just learned, POS was introduced as a more energy-efficient alternative to POW. In POS, validators are chosen to create new blocks and validate transactions based on the amount of cryptocurrency they hold and are willing to stake as collateral. The more tokens a validator stakes, the higher the chances of being selected to validate the next block. Ethereum has transitioned to POS with its Ethereum 2.0 upgrade, aiming to reduce energy consumption and improve scalability. Third, delegated proof of stake, DPoS. DPoS is an evolution of POS. In this system, token holders vote to elect a small number of delegates who are responsible for validating transactions and creating new blocks. This delegation process combines decentralization with efficiency, as a limited number of delegates can reach consensus more quickly. EOS and Tron use DPoS, allowing for faster transaction processing while maintaining a degree of decentralization. Alright, what about private blockchain? Private blockchains indeed use different consensus algorithms and practical Byzantine fault tolerance. PBFT is one of the popular ones. However, PBFT is not the only consensus algorithm used in private blockchains. Here are a few other consensus algorithms commonly used in private blockchains like Raft and Proof of Authority, POA. Now you and Lisa are familiar with consensus algorithms to understand the followings. Let's have a look at blockchain generations. First generation blockchain. Bitcoin, the first P2P cryptocurrency. Our journey begins in 2009 with the release of Bitcoin by Satoshi Nakamoto. This generation focused primarily on enabling secure, peer-to-peer digital currency transactions without the need for intermediaries. This revolutionary system introduced decentralized architecture. No single authority controls the network. Consensus algorithm, proof of work, POW, cryptocurrencies, Bitcoin and Ethereum 1.0. Bitcoin is the first ever DAO. Bitcoin solved a crucial problem by enabling secure, peer-to-peer digital transactions without intermediaries. However, it had limitations. Slow transaction speeds, limited scalability, high energy consumption. Second generation blockchain, Ethereum, the first blockchain platform. Then, the second generation of blockchain technology was spearheaded by the creation of Ethereum in 2015 by Vitalik Buterin and his team. This generation expanded blockchain's capabilities by introducing smart contract. This revolutionary system introduced smart contracts, self-executing contracts with the terms directly written into code, decentralized applications, dApps, application that runs on the blockchain, consensus algorithm, proof of stake, POS, cryptocurrencies, Ethereum 2.0. Bitcoin primarily created DAO for managing cryptocurrencies, while Ethereum expanded the application of DAO with smart contracts. Ethereum is indeed more than just a cryptocurrency. It is a decentralized blockchain platform that enables the creation, registration, and enforcement of smart contracts without the need for intermediaries such as platform companies or financial institutions. This allows for a wide range of decentralized applications, dApps, to be built and run on the Ethereum network, making it a versatile and powerful tool in the blockchain space. This opened up possibilities in decentralized finance, DeFi, non-fungible tokens, NFTs, gaming, and more. But Ethereum has limitations, such as scalability, as it faces challenges with transaction throughput. Third generation blockchain, solving scalability and interoperability. The third generation of blockchain technology aims to address the scalability, interoperability, and sustainability issues of the previous generations. This generation focuses on creating more efficient and interconnected blockchain networks, improved scalability, handling more transactions per second, enhanced interoperability, allowing different blockchains to communicate, reduced energy consumption, more efficient consensus mechanisms, increased customization, tailoring blockchains for specific use cases, innovative consensus mechanisms, adoption of more advanced consensus mechanisms like proof of stake, POS, variance, proof of history, POH, Tendermint BFT Cosmos, and delegated proof of contribution, ICON. Cryptocurrencies, Cardano, Polkadot, Solana. Future generations of blockchain technology are still emerging. Experts anticipate significant advancements, including integration with AI, enhanced privacy features, focus on mass adoption and user-friendly interfaces. We can see that the blockchain is evolving and expanding its use cases. Shall we go over with important bullet points? Public blockchains are for cryptocurrencies and applications that require trust without intermediaries. In contrast, private blockchains are for businesses and regulated industries, offering greater control and privacy. Public and private blockchains use different consensus algorithms. Bitcoin represents the first generation of blockchain. Ethereum represents the second generation of blockchain, and smart contract is the key technology. Well, it looks like Lisa and all of us now have a solid foundation in blockchain to start participating in this exciting field. Thank you so much for watching this video. If you found these videos helpful for your Web3 journey, please subscribe and leave us your feedback on how we can improve or topics you'd like to learn more about. In our next video of Lisa's journey from zero to empowered, we will dive into the world of AI. Lisa is super excited about this new topic.